chapter which has been asked in GATE, and after that we will start the differential equations. Okay. Okay, so what is the complex matrix? If any matrix is having a complex number in the matrix, then it is called complex matrix. And what is transugate of a matrix? The transpose of a conjugate of a matrix is known as transugate of a matrix, which is denoted by A theta A inverse or A bar transpose. So what does that mean? What is conjugate? Suppose this is your complex matrix. So what will be its conjugate? Just you have to replace I to minus I. So conjugate of this matrix will be, and what will the transpose of the conjugate matrix? That will be your conjugate matrix. Sometimes they just ask in exam to calculate the transugate or the few properties that I have written. They ask the question on that, like what is the Hermitian matrix? So a square matrix is said to be a Hermitian matrix if A transugate is equals to A. What is the skew Hermitian matrix? A matrix will be called skew Hermitian matrix if transugate of A will be A. Okay, sorry, here it will be minus A. What is the unitary matrix? If A and A transugate is equals to A transugate into A, which is identity matrix. In real matrix, what is the unitary matrix? Orthogonal matrix. Then the eigenvalues of a Hermitian or a symmetric matrix are always real. The eigenvalues of a skew symmetric matrix are either 0 or pure imaginary. Then eigenvalues of an orthogonal matrix or a unitary matrix has absolute value which will be 1. This is absolute value. It could be minus 1 also. What we do? We add the mod on that. So absolute value will always be 1. Then one more small topic is there, Cayley-Hamilton theorem. Mostly they never ask questions from Cayley-Hamilton theorem because it will be very lengthy. But sometimes they can form a very small question from this topic. So you should just learn this topic a little fast. So we will go little fast here. So what is the theorem? That every square matrix satisfies its characteristic equation. Okay, what does that mean? Like suppose the characteristic equation of a square matrix will this. So every square matrix will satisfy this equation. Now we will do one question, then we will understand what does that mean. Suppose this is a matrix and we will write its characteristic equation, which will be A minus lambda is equals to 0, 1 minus lambda, 3, 2, 4 minus lambda is equals to 0. If you solve this, you will get our equation lambda square minus 5 lambda minus 2 is equals to 0. So according to the theorem, your matrix will satisfy this equation. What does that mean? That means A square minus 5A minus 2I is equals to 0. Okay, this is the equation. So why we learn about this theorem? With this theorem you can easily find the A inverse or greater power of the matrix. So how do we do that? Suppose this was your equation. So you can write this equation like A square minus 5A is equals to 2I. Then you can multiply this equation by A inverse. Then 2I into A inverse, A square A inverse minus 5A A inverse. So A inverse will be 2 A inverse is equals to A minus 5A. So from here you can easily find your A inverse. 1 by 2 A minus 5I. So you need to put a value of A matrix, and I is the identity matrix. In one step you will be able to find the A inverse. Okay. Now we will do one 3 cross 3 matrix with this theorem. Okay. We will write the characteristic equation for this. It will be lambda square minus 1 is equals to 0. When you will solve this equation, it will come as. So according to the theorem, every matrix will satisfy its own characteristic equation. So we can write this equation one as a cube minus a square minus a plus I is equals to 0. If you'll send these terms to other side, you'll get this equation. So suppose they are asking you to find a to the power 4 or a to the power 8 or a to the power 50. So how will you do that? From here, what you have to do, you have to just multiply a in that. Suppose we are multiplying a in this equation, it will be a to the power 4 is equals to a cube plus a square minus a. So what you from this equation, we know the value of a cube. We will put the value of a cube here. It will be a square plus a minus I plus a square minus a. So your a to the power 4 will be 2a square minus I. So you can calculate a square value, and then you can calculate the a to the power 4 from that. Now for a to the power 8, a to the power 8 could be written as a to the power 4 multiplied by a to the power 4. So you can write it as 2a square minus I, 2a square minus I. If you multiply this, it will be coming as 4a to the power 4, 4 e to the power 4 minus 4a square plus I. You can write it as 4 multiplied with 2a square minus I. You will put the value of a to the power 4 again, minus 4a square plus I. From here you can see a to the power 8 will be 4a square minus 3I. Here you can see in this equation, suppose this is equation 3, this is equation 4. There is a pattern. In A is a to the power 4 and a to the power 8. So by that you can write a to the power 50 will be 25a square minus 24i, because suppose what we have seen in a to the power 4, this coefficient was the half of the power, and here just minus this coefficient 1. Same when we just same when we look down a to the power 8, here the coefficient was 4a square, and this coefficient was 4 minus 1. So here we can just we can write it as a to the power 50 will be 25a square minus 24i. From here you can calculate the a to the power 50. So just like that, you have to get the pattern, what pattern it is following. Some pattern will be there, and then you can find the bigger power of some matrix by this theorem. Okay. Now we will solve the problem. I hope that few of the problems you have already solved. So we'll quickly solve all these problems. So this is the first problem in the year 2003. So please solve and tell me the answer. It's a very easy question. Okay. Okay, C is the correct answer. Is there anyone who doesn't know the answer? Okay, okay. Okay, I assume everyone, all of you solved this question and this is a very easy question. Okay. This is the next question. This is also very easy question. Tell me the answer. Okay. Okay, correct. Move on to next question. You solve this question. Tell me the answer.
B, ma'am.
B. Okay. Anyone else?
A, ma'am. A, ma'am.
Sorry.
A,
A. Okay.
A, A.
Okay. Okay. So answer will be A. If any of you are having problem to solve this question, tell me. We will solve it here.
Yes,
Yes,
ma'am.
ma'am.
Yes,
Yes,
ma'am.
yes.
Okay. Okay. We'll solve this question. So this question you can see this it can be divided into block matrix. So how we will solve this question? We will since it's a 4 cross 4 matrix, it will not be easy to for you to calculate eigenvalues then find the eigenvectors. So what we will do, we can find the eigenvalues easily. That trick that I have told you in last class. So if you divide into block matrix, the eigenvalues of this matrix and eigenvalues of this matrix will be the eigenvalues of your matrix. So if you solve this, tell me what will be the eigenvalues. For first one, you can tell me easily. Second one, it will be all complex number. First one, you can just look and tell me the eigenvalue of this matrix. What it will be?
5.
5, correct. So lambda will be 5 and 5. Okay. So now you have two eigenvalues. Okay. So now what we will do, we will go with the option. You know, what are the eigenvectors? The vector which will satisfy this vector which will satisfy this equation. So just to write your matrix 0, 5, 0, 0, 0, 0, 3, 1, x. Now we will go with the option. Firstly, we were lucky, so the answer was first. We will write first vector this one 1 minus 2 0 0, and your lambda is 5. Again we'll write x 1 minus 2 0 0. Okay, solve this. If you'll solve this, it will be coming as 5 minus 10 0 0, and this side also it will be coming as 5 minus 10 0 0. So this answer is satisfying this equation for you. So this will be your answer. Okay, but for the safer side, you'll do for all these three options also. Okay, but here all other three options are not correct. So let's not waste our time. This will be your answer. Any doubts in this question?
No, no, ma'am.
Okay, let's
Ma'am,
yes.
here we have compared with all these options for that answer.
Yeah, you have to because sometimes, suppose what we did, your first option was correct, so it came as answer. But in GATE, multiple options can be correct, so you have to do that. It will not take much time. Like I'm showing you, if you do it on your own, it will hardly take 20-30 seconds with you. Okay.
Okay, ma'am.
Okay. The more you practice, the more less time you will take to do all these things. So keep practicing. Okay, next question. Tell me the answer.
A, ma'am. A.
Okay.
A.
Okay. So you have to read this equation again. This question again. They are asking for both real and symmetric. So we have looked one property yesterday. Sorry, not yesterday. Last session, in which we have seen that it will also be non-negative. So here your answer will be C. Okay. Okay. Now we'll move to next question. Tell me the answer.
Please explain previous one.
Yes. You have any doubts in that?
Explain it. Why non-negative?
So this was a property that we have seen, yes, in a previous session. That depends on that property. Wait, I'll show you. See, in this property, if the all the leading minus of real symmetric matrix are positive, so what does that mean? What does that mean? Leading minus. So here in this question, what they are asking? Symmetric. So suppose if you will take any symmetric matrix, you will check their leading minus. That will be positive also because they have to satisfy this condition. Okay, for symmetric matrix. So this will lie in that property. If it's all leading minus will be positive, its all eigenvalues will be positive.
Okay, ma'am. Thank you.
Okay. Okay, solve this question. See. Anyone else?
C, ma'am. It would be 2.
All of you got C only.
No, ma'am. No, ma'am. It would be 0. Would it be 0? B, ma'am. B.
B. Yeah, B is the correct answer. Okay, we will solve this question also. What is the, suppose firstly we will write its characteristic equation. What will be the eigenvalues?
Two.
Okay. So now we will put the eigenvalues here. So what is the rank of this matrix? What is the rank of this matrix?
0.
No.
1, 1, ma'am.
1.
1.
Okay.
1 month.
So
1,
what
1.
is the linearly independent matrix?
N minus R.
Yes. N minus. What is n here? 2 minus 1, 1. So your answer will be B. Okay, solve this question. It's a very easy question. Tell me fast.
C, ma'am. C.
C. Okay. There's no problem in this question, right? Okay, we'll move on to next question. Solve this question.
B, ma'am. Number 2.
And B.
Okay. B is the correct answer. Everyone got this answer? Any doubts in this question?
Yes, ma'am. No, no.
No, ma'am.
Yes, ma'am. Explain.
Okay, we'll go very quickly for this question also. So this is your matrix. If you solve, you will get two eigenvalues. Lambda is equals to 1 and 2. Okay. Then for lambda is equals to 1, your matrix will be 0, 2, 0, 1. If you'll calculate this, your eigenvector will come as 1 and 0. So from here, one value A or B will be 0. Then you will solve for other eigenvalue. And if you solve this, your eigenvector for this eigenvalue will be coming as 1, 1 by 2. So your B will be 1 by 2. What they asked A plus B. So A plus will be 0 plus 1 by 2. That will be 1 by 2. Okay?
Okay, ma'am. Okay, ma'am.
Okay. Solve this question. Any answers?
A, ma'am. A.
Okay, is the correct answer. Again, if you solve this matrix, if you find eigenvalue that will be coming as 1 and 4, then you will put lambda is equals to 1 in your characteristic matrix, then you will get this as your eigenvector. Okay, so this question, this is
C, ma'am. Always real.
okay. C is correct. Solve this question.
B, madam.
Okay,
B.
B is the correct answer. So what we have to do again, just to find the eigenvalues that will be coming as 2 and 6. When you put lambda is equals to 2, your eigenvectors will be coming in this form. Okay, sorry, this form. So the only matching value will be this. This will be your answer. Solve this question.
And C.
Okay, correct. Any doubts in this question?
Ma'am, will you please explain that, ma'am?
Surely. Okay. Sin x, cos x, tan x, these are all independent functions. So here, but sin square x, cos square x, tan square x, these are not independent function, these are dependent function. But if you'll go through option, here sin x is there, which is independent. Here cos x there, which is independent. In this option, cos 2x is there. Cos 2x can be written as cos square x minus sin square x. So this is again a dependent function. So only this option which is having all the dependent functions. So this is the correct option. Okay. Okay. So again in this question they are asking to find the eigenvectors. Solve this.
Do option do.
Option. Okay, all of you solve this question.
D.
Okay, D is the correct answer. Again, this is a 2 cross 2 matrix. Firstly, you have to calculate the eigenvalues. Your eigenvalues will be 4 comma minus 3. When will you put lambda is equals to 4, then your eigenvalues will be coming as 2 and 9, which is not in the option. So you have to put lambda is equals to minus 3 also. Then you will solve this. Then your eigenvalues will be coming as 1 and 1. So this is your option D. So option D will be your answer. Okay. Solve this question. C. Okay.
Ma'am, zero.
Ma'am,
Zero.
D, D.
Yeah, 0 is the
Zero.
correct answer. Before solving this question, we'll again look on one property that we have seen in previous session. This. The eigenvectors corresponding to the distinct eigenvalues of a real symmetric matrix are always orthogonal. Okay. So here now we'll look on the question. Okay, here what they are saying that your eigenvalues are A and B which are not equal to 0 and A is not is equals to B. That means they are distinct eigenvalues. So the eigenvectors corresponding to these eigenvalues will be orthogonal. So what is the condition for orthogonal? X1 transpose X will be X2 will be 0. Okay. So x1, x2, x3, y1, y2, y3 will be 0. If you multiply this, it will be x1, y1 plus x2, y2 plus x3, y3, which will be 0. So D is your answer. Okay. To solve this question,
Can kindly go to the previous slide?
sorry.
Can you kindly go to the previous slide for me?
Sure, sure.
Yes, ma'am. Thank you.
Okay. Find the minimum eigenvalue here, lowest eigenvalue.
2, madam.
2. Okay. Any doubts in this? If
2,
you'll
madam.
solve,
2.
if you'll solve for eigenvalues, your eigenvalues will be 5 and 2 for this matrix. And here it is asking lowest eigenvalue, that will be 2. 2 will be your answer. Okay. Solve this question.
Yeah, option A, ma'am. Option A.
Option A. Okay. Option A is correct. So again, we will follow one property, that the condition for which eigenvalues of a matrix are positive if the leading minor of that matrix is positive. Okay, so what will be the leading minor of this matrix? That should be positive. Leading minor of this matrix, sorry, characteristic matrix should be positive. So you'll solve this. You'll solve
Ma'am,
this.
you can say the multiplication of the eigenvalues will be equal to the determinant of A.
Yeah, we can do by that also. Okay, if you'll solve.
Leading minor means the minus of the principal diagonal elements.
Okay, here you will get 3 leading minors. So we will take this leading minus for 2 cross 2. And it should be greater than 0. If you solve this, then your k will be coming as greater than.
So why is k is greater than 0?
Wait, there was one property for which if the eigenvalues of the matrix will be positive, if the all leading minus of that matrix is positive.
What are the leading minors?
Wait. We will go back to the. Okay. So how we calculate the minus? Suppose this was your matrix. This was your matrix. So how we calculate the minor? This will be your minor. Then this will be your minor. Then this will be your minor. And then this will be your minor. What will be the leading minor? That will be calculated by the diagonal. And whole matrix, determinant of matrix will also be a minor. Okay. When you go for 3 cross 3, how you calculate minor? 2, 4, 5, 1, 3, 2, 1, 1, 1. Suppose this is your matrix. So if you suppose you cut this element, so this will be your 1 minor. Then if you cut this, so these elements will make 1 minor. Whole matrix will also make 1 minor. This will make 1 minor. This is all your minors. Okay.
Okay.
Okay. Okay, so this
But
question.
leading minus is obtained by closing, like minus is fine, but leading minus is obtained by closing the like first row and first column, right?
Yeah, that is for only 3 cross 3. When you'll go for 2 cross 2, you will get 2 leading minors. Okay, the whole determinant of the matrix will also be a leading minor.
So here the determinant of the matrix and k both are the leading minors, right?
Yes.
Okay.
Okay, I'll look on this question again. Okay, I'll get back to you in next class. Solve this question.
Two, ma'am, two.
Okay. Everyone got the same answer? So this is a triangular matrix. So its eigenvalue will be 2. It's a leading diagonal, which will be this 2, 2, 2, 3 elements of the diagonal. Okay. So what we have to calculate, linearly independent eigenvectors. So this is one distinct eigenvalue. So from this value, definitely you will get one linearly independent eigenvector. Then two repetitive eigenvalues are there. So repetitive eigenvalues, linear eigenvectors may be linearly independent or may be linearly dependent. So for repetitive, you have to calculate. For distinct, it's clearly that it will be linearly independent. So from here, one you will get. For other, we will calculate. We'll put lambda is equals to 2 in a minus lambda I. So you will get. So what will be the rank of A minus lambda I? 2. So number of linearly independent eigenvectors will be number of columns minus rank of A minus lambda I matrix. So here also you will get one linearly independent vector. So 1 we get from this eigenvalue, 1 we get from this eigenvalue, 1 plus 1. The total number of linearly independent vector will be 2. So the answer will be 2. Okay. Any doubts?
Ma'am,
We'll move on to next question. Solve this question.
ma'am, what will be the rank of the matrix?
This matrix A minus lambda I rank will be 2. What is the rank? Number of non-zero rows. Here number of non-zero rows are 2.
Okay, ma'am.
Okay. Solve this question.
Two, ma'am. Option B.
Yes, option B.
This will be very
Six,
simple.
ma'am.
What you have to do is answer this. You have to guess this. Yes, Naman.
Yes, ma'am.
So please put your answer. Solve this question. Fine. Solve this question.
Zero, ma'am, zero.
Okay.
Yes, ma'am. 0.
Okay, any doubts in this question?
No, ma'am.
Okay, the answer will be 0. Well, we move on to next question. Solve this question.
5.
5, correct.
Yes, five.
Any doubts in this question?
No, ma'am.
Okay, solve this question.
One.
1. So lambda will be 1, 1, 1. They are asking number of distinct eigenvalues, which is 1. Okay. solve this question?
Ma'am, D, 16.
Yeah, D is the correct answer. Any doubts in this question?
No.
Explain to once, ma'am.
Okay. What is your equation? Your equation will be this. Here, your lambda x here is given as r, and your x is given also. So you just have to put it here. Lambda x is goes to r, and lambda you have to find. Your x is 214. Here you will write 32, 16, 64. So if you will get 16 out, it will be 16, 214. Lambda is equals to lambda 214 is equals to 16214. So from here you can say that your lambda is 16. Okay.
Yes, ma'am.
Solve this question. Just read this question. Reading you'll get the answer.
And D is the answer.
Yeah, it is D. Okay, so your answer will be D. What is it saying? Consider an n cross n matrix A. Suppose there is one A matrix which is A, and one vector P which is n cross 1. Their product AP. That what are they trying to say? A into X is equals to alpha square P again, which will be lambda into X. So here your lambda is alpha square. Okay. Based on the given information, what is the eigenvalue of A square? So from this equation, you can say that alpha square will be the eigenvalue of A. So what will be the eigenvalue of alpha A square? That would be alpha to the power 4. Okay. Any doubts?
No, ma'am.
Okay. Solve this question. I think this is the last question.
One, ma'am. One.
They're asking the value of P.
Two, ma'am. Two, ma'am.
2, ma'am. Is it 2?
Yeah, Q is coming 1.
Two.
You solve. Q will be coming as 1 and P will be 2. Any doubts in this question?
No, ma'am.
No, ma'am.
Okay.
Yes, ma'am.
We have, sorry? Okay, so we have solved all the question which has been asked in GATE for linear algebra. Here linear algebra we have finished. In the last to last session we have solved around 22, 23 questions. This session also we have solved 22 questions. So that covered all the questions from 2000. Yes. Okay, that
Can you
covered
explain the last one next one, ma'am?
this question.
Yes, ma'am.
Okay. They have given the sum and the product of the eigenvalues. So what will be the sum? 3 plus q is equals to 4. And what will be the product? Determinant of this matrix? 3q minus p square is equals to minus 1. From here you will get q is equals to 1. When you will put the value of q, you will get p is equals to plus minus 2. But they are asking mod p, so you will just write 2. Okay. Okay. Now we will move on. We have already solved all the questions from eigenvalue and eigenvectors, and it's starting we have solved all the questions from matrix, and we also solved all the questions of linear equations, system of linear equations. So calculus is being taught in Saturday session. So I'm skipping calculus. Now we'll start differential equation today. Any doubts in this up to first chapter, linear algebra?
Ma'am, where we will get the notes?
Notes I have uploaded in the drive link. I uploaded 2-3 days back. If you'll check now, you'll get it.
Which drive, ma'am?
Okay, you don't have drive link. After the end of the class, I will share the drive link. Or if any of you have that drive link, please share in the chat box. Okay, now we will start the differential equations. This is the gate syllabus for your this chapter, and this is also a very important chapter. So, what is the syllabus? First order equation, higher order linear equation, Euler-Cauchy equation, initial and boundary value problems, Laplace, solution of heat wave, and Laplace equations. So, today we will try to cover at least first order equations and how to solve first order equations. So what is the definition of a differential equation? A differential equation is an equation which contains one or more terms and the derivatives of one variable, that is your dependent variable, with respect to other variables, that is your independent variables. What does that mean? Just any equation which contains any kind of derivatives is called the differential equation. In this equation, x is an independent variable and y is dependent on x. And another example is like dy by dx is equals to 5x. So what is the use? What is the application of differential equation? Suppose there is a real world problem, any kind of problem. So what we do, we just try to convert that problem into a differential equation, because solving problems in mathematics is easier than as compared to science. So whatever the problem you get, you just try to convert into an equation, and then you solve that equation. After solving that equation, you interpret what will be the real answer. So what is the example or applications of differential equation? Like heat equation. If you look your heat equation and laws of heat, those all are based as differential equation, or you can say wave equation. Those all things are converted, whatever the problems, they are being converted into a differential equation, and then we solve that differential equation, and then we interpret what will be the answer for the real world problem. Okay, let's move on. Sometimes they ask one mark question on the order and degree of a differential equation. So, what's an order? The order of the differential equation is the order of the highest order derivative present in the equation. So, what is the example? Suppose this is dy by dx is equals to 3x plus 2. So, here the highest order of this equation is 1. Here you can see double derivative is there, so the highest order or order of this equation will be 2. Here again first degree is present, so your order will be 1. Then what is the degree? Degree of the differential equation is the power of the highest order derivative, where the original equation is represented in the form of polynomial equation in derivatives such as y dash, y double dash, or y triple dash. Suppose this is the equation. So what will be your degree? The power of the highest order derivative. So highest order derivative is this, and your power is here 1. So the degree of equation will be 1 here. Again, in this question, no, sorry, in this example, this is your equation, and highest order derivative is this, and your power is 1, so your degree will be 1. Here your highest derivative is y triple dash. Y triple dash is what? d3y dx3. Okay. So the power of the highest derivative is 3 here. So your degree will be 3. Okay. Again in this question, it is not a polynomial equation, and we cannot define the degree of such equations. Okay. Only polynomial equations we can define the degree. So we'll see some more example. Suppose this one asked in double E, I guess.
And is the order is also for can be found only for polynomial.
Order you can see now, whatever, like here if your order was, suppose here, order was this, then you can say your order is 2. So this condition is not for order, only for the degree. So tell me what will be the order and the degree of this equation.
Order is 2, ma'am. Degree is 4 by 3, ma'am.
Degree is 4.
Okay, order is 2, degree is 4, one answer other is 4 by 3. Any other answers?
Ma'am, no, ma'am. Order is 2, degree is 4.
Order is 2, degree is 4. Any other
Order is
answer?
2, degree is 4 by 3.
Okay. Any other answer? Okay, when your suppose your power is in fractions, then you just try to convert into the integer. Okay, and you can do that easily. You just write this step. Now tell me the order and degree of this equation. Now you can easily tell what will be the order and what will be the degree. Who got 4 by 3 here? Now can you see?
Order is 2 and 4.
Yeah.
Degree is 4.
Yeah. Firstly, just try to convert your degree power into an integer number. Okay. Then it will be easier to check what is the order and what is the degree. One more example. Tell me the order and degree. Solve this and tell me.
Order is 3.
Order 3, degree 9. Degree is 9.
Okay. Order 3, degree 9. Any other
9.
answers?
Order is 3 and degree is 36.
Okay.
Order is 3 and degree is 1.
Degree 36. Any other answer?
Order 3, degree 9. Order 3, degree 4. Order 3, degree 9, ma'am.
Okay. And degree
5.
4. Okay.
Degree 5. Degree 5.
Degree 6, ma'am.
Degree 3 and sorry. Ma'am, order is 3 and degree is 3 to the power 9. Order 3,
Degree
degree
6,
5.
ma'am.
Order 3, degree 5.
Degree 6, ma'am.
Degree 6. There are so many answers. What is the correct answer?
9, ma'am. 9, ma'am. 9.
Yes, yes, 9, 9, 9, ma'am. 3 and 9. 5.
Okay, I'm not telling the answer for this one. You just read again and try to solve this question. Your order is correct. Everyone got 3. But degree, there are so many answers. So we will see that later. Okay.
9, ma'am. 9.
Okay, we'll see that later. So this is a small topic, formation of a differential equation. they mostly they don't ask such questions, but sometimes they ask. Suppose we'll see this by an example. Suppose one equation is given, x square plus y square plus 2gx is equals to 0. Suppose this equation is given, and then they will ask, what is this? What kind of equation is this?
An equation of circle.
Circle, you can say, or any curves. This is a family of a curves. This equation can be termed as family of curves. So what sometimes they ask, find the differential equation. Find the differential equation for the family of curves, which is this. So what are the steps? Firstly, write the equation of given family of curves. Differentiate as number of time as number of arbitrary constant occurring in it. What is the arbitrary constant here? Just g. Only one constant is there. So how many times you have to differentiate this equation? One time only. So you will differentiate this equation with respect to x. And from here, you'll get the value of g. The next step is eliminate the arbitrary constant from the given equations by using the equation obtained in step 1 and step 2. This is step 1. This is your step 2. So here from here you can calculate the value of g. That will be, if you multiply by 2, that will be minus x minus y dy by dx. So from these two equations, you can write this equation as x square plus y square plus 2x minus x minus y dy by dx is equals to 0. If you solve this equation, simplify this equation, you'll get as 2xy dy by dx. So this is your differential equation. Okay, sometimes they will give you a equation or a family of curves equation, and they will ask you to write a differential equation. Or they will give you one equation and they will give you 4 options. They will ask what will be the differential equation of this family of curves. So now let's move on to the solution of first order differential equation. Okay, there are 5 or 6 types of first order differential equation. First order means only your order of derivative will be 1 here. Okay, so there are 4, 5 or 6 types that we will see in this class. Today I will tell you all the types, and we will solve the question in the next class. Okay, so first type is variable separable. So suppose your dy by dx is equals to f of x and f of y. You can easily distinguish the function of x and the function of y, and this is called variable separable. So how we solve such kind of equation? Suppose let's take one example. Dy by dx is equals to e to the power x minus y plus x square e minus y. This is a variable separable equation. How can you write this one again? Dy by dx is equals to e to the power x by e to the power y plus x square e to the power y. E to the power y into dy by dx is equals to e to the power x plus x square. So here you can take all y terms in one side and all x terms on other side. So this is called variable separable. Now easily what you have to do, you will integrate this equation and you will get the solution. Your solution will be e to the power y is equals to e to the power x cubed by 3 plus c. You can take a log also, and you can find the value of in terms of just y also. Okay, that will be your answer. The other type is reducible to variable separable. What are this type? They will just give you one differential equation. From that differential equation, you have to find out which type it belongs, and after getting which type, then you have to know how to solve that type of equation. Okay, there are 5-6 type of equation in first order. First order we will complete today, second order and partial differential equation, and all the gate equation we will do in the next session. So second type is reducible to variable separable. Suppose your equation is in this term. So you have to, how will you reduce this, or you have to reduce this? So firstly, there are few steps. Suppose your both the function, suppose it is in terms of dy by dx is equals to sine x plus y. So here what will you do? Simply you will just assume x plus y is equals to t, the way we used to do in 12th standard, and you'll replace this by x plus y is equals to t, and then that it will be converted as dt by dx minus 1 is equals to sin t. Now it is reducible to variable. Now it converted into a variable separable. Sin t dx, from here dt divided by 1 plus sin t is equals to dx. Now easily you will integrate this kind of, now you know how to integrate this kind of equation. After you will integrate, you will get the answer something like tan t minus sec t is equals to x plus x plus c, and then again you will put the value of t, so your answer will be tan x plus y x plus y is equals to x plus c. That will be your answer. One more type in reducible to variable separable is, suppose your equation is given in this form: dy by dx function of x y, then f2 function of xy, where f1 and f2 are homogeneous functions of same degree. So how to solve such kind of equation? What we will do, we will put y is equals to vx, then from here dy by dx is equals to v plus x dv by dx. Okay, we'll do one example for this kind. Dy by dx is equals to x cube multiplied by y divided by x cube plus y cube. Okay, so here you will do here you can see what is the degree 3. Here also the degree is 3. Okay, so this is a f1 f2 are homogeneous function of same degree. Okay, so now we will put y is equals to vx.
This is a third type.
Sorry, this comes into second only, reducible to variable separable. Firstly, if, they will give you simple like sine x plus y, where you have to, if any trigonometric function is coming such like that, you have to just assume this part as t. Okay. Second, if they are given in this part, like this kind of, this is the second kind, but it comes into reducible to variable separable only. Okay.
Alright.
Okay, and we will put dy by dx is equals to v plus x dv by dx. So you will put the values. It will be v plus x dv by dx is equals to v x cube divided by x cube plus v cube into x cube. Okay, then you will solve this will be coming as v plus x dv by dx is equals to v divided by 1 plus v cube. You will shift this v to other side. X dv by dx is equals to v minus v to the power 4 divided by 1 plus v cube. V to v cancel. X dv by dx is equals to minus v to the power 4 divided by 1 plus v cube. Now 1 plus v cube into dv is equals to 1 by x dx. Now this is variable separable. One variable this side, one variable other side. Now you can easily integrate this and you can solve this. After you will integrate and solve this, it will come something like your answer. After you solve this, some value will come. Then you will put the value of v is v as y by x, as we assume y is equals to vx. So you'll put the value of v. So your final answer will be ln y x cube divided by 3y cube plus c. These kind of questions are lengthy, so they actually don't ask much from this style. Mostly they ask from second order. Okay, we'll solve one more question on this
Ma'am,
type.
can we show the previous slide?
Sure.
Okay, ma'am.
Okay, we'll solve one more example very quickly and then we'll move on to next type. Suppose this is again one equation. Y by x tan. Okay, tell me what is the type here? In previous both two types, what is the type here?
Second type.
Second type.
Second one, ma'am. Second one.
Try to solve this. If it's reducible to variable separable, what you have to do? Put y is equals to vx and dy by dx is equals to v plus x dv by dx. Put this and tell me the final answer. Or just tell me from where you have to integrate, because integration will take time. Before that, just tell me what will be the separable form of this equation.
Ma'am, dt upon
Ma'am,
tan t
dv by
is
tan
equal
v
to
equals
dx upon x.
dx by x.
Yeah, repeat.
dv by tan v equals dx by x.
Okay, this is correct. This is correct. Any other answer? Any other form? Okay, after you will put this, v plus x dv by dx will be v plus tan v. Then it will be x dv by dx is equals to tan v. Then you will get this equation. Then you have to integrate this equation. When you will integrate, cot v dv is equals to 1 by x dx. It will be log sin v is equals to x plus lc. Then sin v is equals to xc. So we'll put the v is equals to y by x is equals to xc. This will be the solution of your equation. Okay. Now,
Yes, ma'am.
Ma'am, these type of sums will come under 2 marks, ma'am.
yeah, they can ask question 2 mark question.
Okay.
Let's move on to the third type. That is linear differential equation. Linear differential equation is important. So a differential equation is said to be linear differential equation if the dependent variable and its differential coefficient occurring with the first degree and they are not multiplied together. What they are saying that it should have first degree and it is not multiplied together. Okay, so what are the examples for the linear differential equation? Dy by dx plus 2y is equals to x cube. This is a linear differential equation. Then your degree is 1 here. dy by dx minus xy is equals to x square y cube. Okay, tell me, is it a linear or non-linear?
Linear, ma'am.
Linear, man.
Non-linear.
Okay, yeah. One more thing that I have said in the definition that it should have first degree and the dependent and independent variables or their derivatives are not multiplied together. So in this equation, dependent and independent variable is multiplied together. So this is a non-linear equation. Okay. Now tell me, what is this equation?
Non-linear. Linear.
Linear. Okay. What will be the order in this equation?
2. 2, ma'am. Second.
First one, first one.
1.
1, ma'am.
And what will be the order in the last one?
2, ma'am.
2.
2.
Okay. So that's how we solve the problem. Firstly, we look first order linear differential equation, and then we will move on to second order linear differential. They ask so many questions from the second order linear differential equation. So that we will see in next session. So what is the standard form for a first order linear differential equation? Dy by dx plus py is equals to q, where p and q are function of x. So what will be the solution of this equation? Solution of this equation will be y into integrating factor, integration of q multiplied by integrating factor into dx. And what will be the integrating factor here? E to the power integration of p dx. Okay. This is very important. You just learn this by your heart because they ask lots of time linear differential equation and they'll ask the solution for that. So this is the solution for this kind of linear equation. Now we'll look this by one example. Suppose one equation is there, dy by dx plus 2xy is equals to e to the power minus x square, and they have given one boundary condition, y at x is equals to 0 is equal to 1. So firstly, this is a form of linear differential equation. dy by dx plus py is equals to q. Easily you can see this is a form of linear differential equation where your p is equals to 2x and your q is equals to e to the power minus x square. So what we have to find? We have to firstly find the integrating factor, which is e to the power integration of p dx. So it will be e to the power integration of 2x dx. It will be e to the power x square. Okay. What is the solution? Y into integrating factor is equals to integration of q multiplied by integrating factor dot dx plus c. So here you can write y multiplied by e to the power x square. Q is already e to the power minus x square. It will be e to the power x square dx plus c. So your answer will be y e to the power x square. This will be cancelled. This both will be cancelled, and your integration of 1 dx will be x plus c. Here they have given you one boundary condition. So by putting this boundary condition, you can get the value of c. What they are saying, at x is equals to 0, y is equals to 1. So you'll put x is equals to 0 in this equation and y is equals to 1. 1, 1, x is equals to 0 plus c. So here your c will be 1. So what will be the final solution of this equation? Y multiplied by e to the power x square is equals to x plus 1, or you can write y is equals to e to the power minus x square x plus 1. This will be the solution of this linear differential equation. Okay. Sorry.
Actually, can you kindly repeat how linear differential equation not should be like two terms should not be multiplied at all? Can you kindly repeat that point?
Yeah. Your degree should be always 1, and your dependent and independent variable or their derivative are not multiplied together.
Okay.
Okay, any doubts? Yeah.
I'm answering a repeat, ma'am.
This one?
Yes, ma'am.
It is y is equals to e to the power minus x square multiplied by x plus 1.
I'm from beginning, ma'am.
From beginning. Okay, this was your linear differential equation, which was in this form, standard form, dy by dx plus py is equals to q, where p and q are the function of x only. So if you will compare, you can see your p is equals to 2x here, your q is equals to e to the power minus x square. So firstly, what you have to do, you have to calculate the integrating factor. What is the integrating factor here? E to the power integration of p dx. So e to the power integration of p dx, here your p is 2x. Okay, and integration of x is x square by 2. X square by 2 multiplied by 2, 2 to cancel. Your integrating factor will be e to the power x square. Now what is the solution of this kind of equation is y multiplied by integrating factor is equals to integration of q multiplied by integrating factor dot dx plus c. So here you write y integrating factor is same the solution I have written. Then I have put it the value of e to the power integrating factor, which is e to the power x square. Here q was e to the power minus x square, and your integrating factor was e to the power x square, so it got cancelled. Minus x square plus x square. Okay, it will be e to the power 0, that will come as 1, and integration of 1 dot dx will be x. C was already there. So this is the solution of your equation that is given. And they have also given one boundary condition, that is if x is equals to 0, your y will be 1. If you'll put this into this equation, y as 1 and x is equals to 0, you can get the value of c. which is coming as 1. When you put the value of c in this equation, this is your final answer, which is y e to the power x square is equals to x plus 1. I just send this e to the power x square onto the right hand side. Understand? Okay, I assume you understood that. One more question we will solve of second order. We'll do it second order in next class. We'll do one more question on the first order. X square dy by dx plus 2xy is equals to 2 ln x divided by x. Boundary condition are y at x is equals to 1 is equals to 0. Then they are asking what will be y at x is equals to e. Try to solve this question. Okay, firstly, divide with the x square. Your voice is breaking. This is your linear differential equation. Now p is equals to 2 by x. So integrating factor will be e to the power integration of 2 by x dx. If you solve this, it will be 2 ln x, which if you solve this, it will be termed as x square. Okay?
Excuse me, ma'am.
Yes, correct.
Ma'am,
Integrating factor coming as x
Ma'am,
square.
that is 2 ln x by x cube, I guess.
ma'am, 2
Yeah,
upon
yeah.
x over.
Okay. Okay. Now what will be the solution? Y into integrating factor is equals to integration of q multiplied by integrating factor dot dx. Y into x square, that will be integration of ln x divided by x dot dx. So I hope that you all know these kind of integration, how we do integration of this. We'll apply the isolate. This will be the first function. This will
ln
be
x. Yes, ma'am.
this will be the first function. This will be the second function. So if you'll solve this by the formula of first function, second function, isolate, this will be coming as ln x square. Okay. Then you'll put here y square is equals to,
मैम ln x square upon 2 आएगा ना.
but this whole term I'm telling, this whole term.
Okay, okay, okay.
Okay. Ln x square plus c. So firstly, if you'll put x is equals to 1 and y is equals to 0, you'll get the value of c, which will be coming as, what is the value of c here?
0.
0, 0.
And they are asking why when x is equals to e. When you put x is equals to e here, y will be 1 by e square. Okay. Okay, I'm giving two equations for you to do as a homework. and then we will move on to the next type. First equation is solve dy by dx minus xy is equals to x cube y square. Second, solve dy by dx plus x sine 2y is equals to x cube cos square y. Okay, solve these two equations and get the solution. Now we will move on to the fourth type, exact differential equations. So the differential equation m dx plus n dy is equals to 0 is said to be an exact differential equation if partial derivative of del m by del y is equals to del n by del x. Then the solution of this kind of equation will be integration of m dot dx plus integration of terms in n free from x dy is equals to c. Okay. So what is the, we'll do one example. We'll do one example which is xy square plus x into dx plus x square minus y dy is equals to 0. So m dx plus n dy will be exact differential equation if del m by del y is equals to del n by del x. So you have to differentiate this term with respect to y and this term with respect to x. If they are coming equal, then we'll use this equation as the solution of this differential equation. So we'll do that. Firstly, del m by del y will come as 2xy. Then we'll do del n by del x. This will also come as 2xy. So this is an exact differential equation. So
Ma'am, will you go to the previous line, ma'am? Thank you, ma'am.
So what will be the solution? Integration of m dx plus integration of terms in n free from x dy is equal to c. So integration of m dx will be xy square plus x into dx plus integration of terms in n which are free from x. So we will take just this term.
Ma'am,
Yes.
ma'am, del n should be 2x, right?
Yes, ma'am. There is no y. Y is absent. X square y. There will be x square y.
Okay. Sorry. This will be x square y. Your n will be x square y minus y. Sorry. Okay. So this will be minus y dy is equals to c. When you integrate this, it will come as y square x squared by 2 plus x square by 2 minus y square by 2 is equals to c. Your answer will be x square y square plus x square minus y square is equals to 2c. Okay. 3-4 more things. Suppose it is not an exact differential equation. So what we have to do, you will do if m and n are homogeneous functions of same degree, Then integrating factor will be 1 plus mx plus ny. Second, if m and n are not homogeneous functions, then their integrating factor will be e to the power, integrating factor will be 1 upon mx minus ny, or m is equals to y function of xy and n is equals to x function of xy. Third, del y minus del n by del x divided by n is equals to fx, or constant, then integrating factor will be